All right, everybody, I do believe we are starting. Thank you for coming this afternoon. My name is Levi Broderick. I am a developer on the ASP.NET team at Microsoft. And the talk this afternoon is going to be a deep dive, improving performance in your ASP.NET application. A disclaimer before we start. This talk isn't necessarily going to be a complete how-to on how to identify performance problems in your application. There are other talks at this conference. The Application Insights talk is right after this one, I believe at 5:30 p.m. So, go to talks like that if you want more information on this subject. What this talk is going to be is about the types of things that we see pretty frequently when we go meet customers on site, and the types of anti-patterns and the types of common mistakes that we see, and the types of solutions that we give to those customers, workarounds, as it were. So I have here a statement on the screen: requests per second isn't everything. Now, why do I say this? A lot of people are under the mindset that when you talk about performance in a web application, you're talking about throughput. Throughput is king. Throughput is all that matters. And there is some truth to the fact that throughput is an important metric. You don't want your application to suddenly fall down in the face of a burst of workload. But at the same time, just thinking about throughput is kind of missing the bigger picture as far as performance goes. So one of the ways that I want to think about performance for this talk is I want to think about performance as in the sense of how efficiently does an application manage its resources. Now, what is a resource? Well, there are tons of different resources that your application might use. Your application might use network. That could be a factor that relates to throughput. It could use the hard disk. It could use memory. Now, depending on the kind of application that you write, you might be consuming more than these resources. This isn't meant to be, a complete enumeration of all possible resources. Your application, if it's simple, might only use one or two of these. Now, when I say resources, I say that applications consume resources. This implies that resources are finite. And when you run out of a resource, what do you have to do? You have to somehow acquire more of that resource. So if you have an application that is inefficient in terms of the particular scenario that it's trying to achieve, sure, you could let the application continue to run and you can just simply throw more and more and more resources at it, but in the end, this might not necessarily be as cost-effective as you would want for your application. Now, how do you figure out what type of modifications you might need to make to your application? How do you know whether the particular resources that your application is consuming is sufficient? How do you know that you're not over-consuming resources? Well, whenever you make an application, you set a series of goals for yourself, right? So one particular scenario might be, I have an application that's an intranet application, and maybe I only ever expect a maximum workload of 10 concurrent users. Now, an application like this might fit comfortably on a single server inside of your intranet. Maybe your web server is a dual-core machine with 4 gigs of RAM, and maybe the application is consuming 2 gigs of RAM because you're storing very large objects in proc session state. Now, for a 10-person capacity intranet application, that's probably perfectly fine. If you remember back to the earlier slide, I listed development time as one of the finite resources that will cost you money. If the cost-benefit analysis of making your application slimmer just to hold 10 concurrent users, like if you do that cost-benefit analysis, you'll probably conclude that, the application's working. I don't really need it to use any less memory. It fits my needs perfectly, and my time is better spent working on maybe the next project that my boss wants to assign me to. On the other hand, if you have an internet-facing application with 100,000 concurrent users at peak, then you absolutely do care about memory. Because if each request is taking up, even something as small as, 1 megabyte of memory, that's For a 100,000 concurrent user application times 1 megabyte, that's a lot of memory. Your memory is going to be a bottleneck in that application. So it certainly behooves you to spend some extra time to try to slim down your application's memory footprint. Again, it's a cost-benefit analysis, right? It's more worth our time. It's more worth the energy to spend the time, spend the resources to improve the application so that we don't have to go buy 50 machines to host this thing. Now, another disclaimer. One of the things that I'm going to do at this talk is I am going to run some performance throughput footprint tests, live on stage. The laptop that I have is a laptop set up for development. If you've looked at the other keynotes, you might see that little text in the bottom right-hand corner of the screen saying, Windows for test purposes only. This is a development machine. This is running a client operating system. Like this is not the same kind of environment that you're going to have if you were to deploy a web server in the real world. And I'm running tests against localhost also. Now, this means that the numbers are going to be, skewed in one direction or another. Tests that go against localhost, they might be really, really fast because, I'm not actually going across a network. That's not bottlenecking me. On the other hand, because this is a dual-core machine and it's a laptop, if a number wouldn't have been performant in the real world, it might be artificially low here. So instead of looking at absolute numbers, what I'm going to do here is I'm going to look at ratios. If we make a change, I want to see how that affects things like throughput or footprint for my website. So without further ado, let's get started. The first thing that I want to talk about is output caching. Now, output caching is, one very popular way that you can increase the responsiveness and the availability of your website. Now, there are all kinds of output caches out there, right? If you imagine how a request comes into ASP.NET, the very first thing it hits, aside from the network layer, is HTTP.sys, which is a kernel-level component that is responsible for implementing the web server in the Windows operating system. Above that, you get IIS, which is the W3WP.exe process that most of you are probably familiar with. And inside of IIS is hosted ASP.NET. That's system web and all of its friends. Now, there are 3 components here on the server, and each of those 3 components implements its own output cache. And when I say output cache, what I mean is an entire response, status code headers, entity body, the whole shebang. Now, obviously, the lower in the stack you can cache a response, the more performant your website is going to be, the less latency your users are going to see when they're accessing your website. Even better, if you can somehow get your pages cached in an intermediary proxy, or even on the client itself, that's also goodness, right? And there are ways that you do that, the cache control public response header. There are also various directives that you can put in there to control how proxies will cache the response. What I'm going to focus on is how do you do this on the server? So let me go over to my demo machine. Demo machine, you all see that? Yes. Oh, that's a nice transition. Okay. So the typical way, I'm going to zoom in just so you can all see that a little bit easier. Now, what I have here is just a very, very simple web forms application. This is Hello World, right? Exciting, I know. And I'm outputting the current time. And you can see I also have an output cache directive on the page. And this output cache directive is going to hopefully say, cache this page, server side and client side, everywhere, for 30 seconds. This means that if I hit Control F5 and keep hitting this page over and over and over again, I should see that time, only increment once every 30 seconds. The page should be cached for a 30-second block. Now, I run this 408.54, 408.57. Well, this isn't behaving as I expect. For some reason, the output cache is being disabled. If I go and I do a throughput test of this, yes, the application is, it's returning 200, okay. It's returning, it's returning the actual page. It's not an error. Let me just go run a throughput test real fast. Oh, wow. Yes. There, you're now offline. Okay. So you can see that this page is serving around 3,400 requests a second. Keep in mind what I said about this being a test on my local box. Don't really look at absolute numbers. Now, obviously, if I'm doing output caching, my website had really better, I really need to do better than this. So why did that fail? Why did that not work as I expected? Well, in the output caching world in ASP.NET, there are some gotchas that a lot of people run into frequently that could actually affect how the output cache works. Now, I've listed 5 of the most common ones on the screen here, but the one that's probably the most common out of this whole set is that one in the middle. It's pretty common for applications to set a response cookie. Maybe they're doing A/B testing, maybe they're setting an affinity cookie, the cookie could be anything. But one of the aspects of ASP.NET is that if you have a response cookie, if you have a set cookie header as part of the response, we will actually disable server-side output caching all the way up and down the stack. We made this change a few years ago, and as you might expect, it is a security change. We did find issues where some applications were having authentication cookies output cached as part of the response. So we have wholesale disabled caching if the set cookie response header is present. Now, let me go back to my demo machine, and I can actually show you, yep, that is indeed what was wrong with this application. As part of my code behind, I was in fact setting a response cookie. If I go ahead and disable that, yep, that's fine, and go make these requests some more, you can see that this request, 4.11.26, 4.11.26, 4.11.26, it is being properly output cached. And if I wait 30 seconds and hit that again, then I will see 4.11.56. Now, if I go and run my throughput test, I should see considerably better numbers than whatever I was getting earlier, which I think was 3,400 requests a second. Again, localhost, don't look at absolute numbers, but the ratio is considerably better. If you can get the server-side output caching working low enough in the stack, you can definitely increase the throughput and lower the latency for your web application, and you can make it more available to your users. Now, as a trick, if you do need to be able to cache a response cookie, there is a property that we added in .NET 4.5. You'll see httpcookie.shareable. The default value is false. You can say, I want this cookie to be shareable, which means if this cookie is present in the response, allow it to be cached anyway. I do not want the presence of this cookie to disable the server-side output cache. So that is output caching in a nutshell. Now, another thing that we often see customers do is, how many of you are familiar with the concept of RAMMFAR, or how many of you have seen this in your web config? I see a small handful of people. Chances are, of the overwhelming majority of you that didn't raise your hands, chances are you have actually seen this. You probably didn't know what it did. Let me explain where it comes from. It is this thing inside your web.config file. I can't type and talk at the same time, apparently. System web server with a capital S, yes. So, modules, run all managed modules for all requests. Thank you. Run all managed modules for all requests, there we go. This thing. Now, this is what we affectionately refer to as RAMMFAR. What this does is this causes the ASP.NET runtime, IIS and System Web basically have this handshake where IIS will run every single request through the ASP.NET pipeline, even requests for files that wouldn't have otherwise come to us. For instance, text files, CSS, other static things. If you host both PHP and ASP.NET in the same application, RAMMFAR is what we'll use, to see if RAMMFAR is what you can use to run ASP.NET Forms authentication in front of your PHP endpoints, for instance. Absolutely a supported scenario, and that's what RAMMFAR was intended for. Run all managed modules for all requests. Now, I do have a RAMMFAR example here, which is here, perf RAMMFAR. So again, what I have here is a text file. It just says, I'm a static text file, hello world. And in web.config, I have turned on RAMMFAR. Okay, I'm also turning off the output cache here, just so that we can measure the raw overhead of ASP.NET as opposed to letting IIS handle the request without calling into us. Now, if I go ahead and run this and navigate to the text file, textfile.txt, there we go. Run that through Fiddler. And by the way, I have, if you're not familiar with Fiddler or you're not familiar with the WCAT tool that I'm using to run these tests, I have links to all of these at the end of the slide, and it'll be made available too as part of the video. So, yep, here you can see it absolutely is serving the static text file. You know, just a very quick throughput measurement. I don't remember offhand what this is going to return because I've changed my machine in the past 2 days since I did this demo. Let's see here. So we're getting around 11,500 requests a second. This number is going to, you know, wobble a little bit up and down as the test runs. But let's just say 11,500, 12,000 is around the ballpark figure. Now, why was that? This is just serving a static text file. That should have been fast. And the reason for it is this. Again, run all managed modules for all requests. This is, again, telling ASP.NET, even if you're not going to do anything, IIS still needs to take the time to call into ASP.NET because IIS doesn't know that we were just going to no-op when we saw this request. So if I go ahead and set that to false, saying, hey, IIS, static file, cool, you handle it yourself, I don't want anything to do with it. Rerun this test, and apologies, it takes around 10 seconds for the numbers to come up. But once the numbers come up, you should see that the throughput is considerably better. If I were to look at memory overhead or, you know, garbage collection CPU utilization, you would see that all of those numbers are also, you know, more in line with what you would expect for static file serving. So, quick summary of RAMMFAR. RAMMFAR tells ASP.NET, I don't care who the request was intended for, I want you to try to handle it, and if you can't, then fall back to the static file handler or whatever IIS would have done. And again, the primary scenario for this was, you wanted ASP.NET Forms authentication to secure your static files or secure your PHP endpoint or secure, you know, some non-ASP.NET endpoint. Now, if you do have this turned on in your website, you know, ask yourself, do you really have to enable this? Now, maybe your static files really are just static files like CSS and images, and maybe you don't care who can see them. In that case, you know, if you do have to have RAMMFAR on because maybe you still want to authorize your PHP endpoints, I would suggest taking your static content and maybe moving it to a different host. Maybe instead of being underneath example.com, it's underneath static.example.com. Move your images, move your CSS there, and for that particular application pool, you can enable static file output caching. That is a setting inside of IIS. You can disable ASP.NET for that entire app pool because, again, we don't really need to be involved for static file serving. If you need to be on the same host name, like if you don't have the ability to move to static.example.com, then maybe you can use an application pool that's a sub-application of your primary website and do the same tricks there. Turn on output caching, turn off ASP.NET, turn off all unnecessary things for that sub-application. Next thing that I want to talk about is session state. Now, interesting thing about session state, it is turned on by default for ASP.NET. So this would be for web forms, for MVC. You will get the ability to read from and write to session automatically. For something like ASP.NET Web API, I don't believe it integrates natively with session state, so you would need to turn that on yourself if you wanted to. Now, session state is, you know, it's mixed. We on the team have, you know, both good and bad feelings toward it. On one hand, you know, it's a really great way to, add statefulness to your web application. Your users expect that you don't lose their shopping cart as you're navigating between pages on the site. But on the other hand, we have to store all of this information server-side. Again, resource consumption. There's a cookie that gets sent back and forth between the client and the server. Maybe the session state data is stored in memory, in process, rather. Maybe it's stored out of process, but still on the same machine. Maybe it's stored in a SQL database. Again, resource consumption. Now, one of the interesting things about session state is that session state requests have to be serialized. If you're a user and you open two tabs, both going to the same website, and you have a particular session associated with your browser, what ASP.NET does under the covers is it will process one request in its entirety, and then it will process the second request, even though from your perspective they were both made simultaneously. And the reason for this is that we don't necessarily know what changes you as an application developer are going to be making to the session object. So we don't want to risk having two applications try to touch a data structure that's not fundamentally thread safe. Now, how does this actually manifest itself? I'll remember to switch back over to the demo machine now. This manifests itself here, session. So, view in browser. What I have here is a dummy web page. It just says, hello. But one of the things that this web page does is it has, let me zoom in a little bit. It has a delay in there to just simulate doing some amount of work, and it's storing some small piece of information inside of view state. It's just putting some 4K blob in there. Now, by default, this is going to be stored in memory. So if I recycle my application, or if I touch web config, I lose session. If I go ahead and put this into Fiddler and just make a bunch of simultaneous requests to this website, you know what? The reason that did not work is because I'm not sending the session cookie. Capture traffic. Oh no, this was working perfectly. Okay, we'll do it this way. Okay, great. Refresh all. Now, going to zoom to the top of the screen, you see all of those throbbers as the tabs load. Even though I hit refresh all, they're loading serially, correct? They take once a second, one of them is loading. So, this one, then this one over here. I have these eight tabs available. I hit refresh all, and it takes 8 seconds for all of them to come back, even though the requests are being made parallel. Now, what I can do here is, you know what? I don't actually. Oh, zoom it. You are fickle. There we go. What I can do here is, inside of this ASPX file, I can say, you know what? I know that I have a session cookie, but I don't actually want to use session at all for this page. This page does not consume session. So I can say enable session state equals false, for instance. And once I save this and go back to IE and refresh all these tabs, refresh, you should see that they all basically load in parallel. And the reason for that was, even though you had the session cookie present, ASP.NET saw that the page didn't require session, so didn't bother serializing access for those requests. It just said, sure, let them all through at the same time. What harm could come? So that is just one of the gotchas with session. If you need to disable session state, for web forms, you can use the enable session state attribute on the page directive, as I just did. For MVC, you can use a controller level attribute. And, okay, great. Next thing I want to talk about is app suspension. And this is really meant for hosters rather than for individual application developers, but it's something that I wanted to touch on. It's a new feature that we added to Server 2012 R2. Because this demo is running Windows 8.1 client, you'll also see that that works here too. So let me just get the application running real fast. What does this application do? It is a simple application inside of global ASAX. I'm simply logging the application starts, and every 5 seconds, I also write a timer fired message to the log. This call to gchandle.alloc, like not really terribly important. All it means is that the timer is not eligible for garbage collection, because otherwise, if nobody references the timer, the GC will eventually claim it. The logger class is also very simple. It's just writing to a static list of string. Keep in mind this is an in-memory log. If the application goes away, if I touch webconfig, if the process dies, this log will be lost. And default.aspx, I'm enumerating through the log and just dumping out entries. And this is exactly what you would expect, right? The very first time I hit the website, IIS spins up the worker process, I get an application started message, and every 5 seconds, like clockwork, every 5 seconds, I'll get a new message written to the event log as the timer fires. So I'm just going to let that application run for a few minutes, and we'll come back to it in a minute. I'm going to run ahead to HttpRuntime.Cache. Now, this is the object cache in ASP.NET as opposed to the output cache. The object cache is a way for you to say, hey, I calculated this expensive piece of data, and I just want to put it in a simple in-memory cache. If it gets removed, I can always recalculate it, but please try not to remove it unless there's memory pressure in the system. Now, again, you could do this with a straight-up static or a straight-up dictionary of string object, but again, you now need to be responsible for taking care of memory pressure on your own. One of the nice things about HttpRuntime.Cache is that we take care of emptying non-recently used items from the cache as memory pressure grows. Another thing that you can do is when you add an item to the cache, you can say things like, if this item is removed, I want you to invoke this delegate so that I can take action. So that maybe, if an item was removed due to memory pressure, maybe I want to log that somewhere. Or maybe I can say, add this item to the cache. Oh, and by the way, hook up a SQL dependency. So if this particular query in the database changes, then I want the cache to be invalidated. I don't have a demo for this. Hopefully, all of you are familiar with HttpRuntime.Cache. If not, I encourage you to look this up on MSDN, look at some samples for using it. It is, quite a powerful thing. In fact, so many people were using it outside of ASP.NET, they were actually bringing in a system web dependency from their WinForms applications just so they could use this cache. In .NET 4.0, we moved it into system.runtime.caching.dll. So if you have a WinForms or non-ASP.NET application, you can actually use the object cache type in this assembly, system runtime caching. That way you don't need to take a dependency on system web inside your own app anymore. Long-running requests. So in ASP.NET, we do have a bit of overhead for each request that comes into the server. Each particular request for an out-of-box template file new project takes around 25 to 30K of overhead, of RAM. Now, once you start scaling this up to 50,000 concurrent connections, multiply that by 30 kilobytes of RAM, and all of a sudden, we're talking about hundreds of megabytes, gigabytes of RAM just in overhead for holding on to all of these connections. Now, we see that this happens for applications that do long-running requests. So this would be long polling or server-sent events, streaming. In .NET 4.5, we added support for WebSockets. It's also built into Windows 8 and Windows Server 2012. And we do encourage you, if you do have long-running requests, to try to run those requests over WebSockets instead of over the standard ASP.NET pipeline. The reason we say this is, like I said, ASP.NET has around 30K of memory overhead per request. WebSockets has closer to 10K of memory overhead. And we are doing work to try to lower even that number down below 10K. If you use a framework like SignalR, which is really meant for real-time communication, long-running requests, SignalR will try to negotiate the best transport between the client and the server. So if your client or your server does not support WebSockets, SignalR will fall back to server-sent events or long polling. And yes, they're not as efficient, but if you can get maybe 80% of your clients on WebSockets using SignalR, and you have a long-running service, then the memory savings for your application are quite immense at that point. Now, another thing that we added for 4.5 is async await. And we could have hours upon hours of talks on this one subject, but why async await? Well, in the list of all resources that I mentioned earlier, thread pool threads are another resource. When a request comes into ASP.NET, it runs on the CLR thread pool. If those threads are blocked because maybe you're doing database access, maybe you're doing synchronous file access, that's a thread that's unavailable to service a request into the ASP.NET runtime. So why async await? Basically, more efficient use of threads. If you're busy doing I/O, then this thread, which is really meant for executing things on the current CPU, that thread can get released back into the thread pool, and then ASP.NET can pick it up and serve a request on it. All of that said, I'm not going to demo async await here. There are tons and tons of papers and videos on this. I have a link at the end of this on one particular talk that we gave at ASPConf around a year or two ago. Here, I'm hoping to actually present fresh content that you can't really watch a video of in your hotel room. Now that I've gone through async await, let me go back to my demo machine and go back to this demo that I've been having run in the background. You can see the last time that I refreshed this page was at 4:25 p.m. If I go ahead and hit Control-R, just give it around 10 seconds or so and hit refresh again. Let me zoom in. Something interesting happened here. The timer's firing every 5 seconds, as you would expect, until this point. There's around 4 minutes where the timer's not firing. What happened here? Well, you saw the code for my application. I'm not doing anything to change the timer. You saw that this was backed by a static list of string, so it's not like the process was terminated and then came back up as IIS normally does. What is this? This is the app suspension feature I mentioned earlier that we added into Windows Server 2012 R2. What this allows you to do is this allows you to configure your application pool to say, instead of terminating the application pool when there are no connections, when the application pool is idle per IIS, instead of terminating the process, I want you to suspend it. Suspension being very, very similar to how Windows Phone will suspend a process or how the Windows Store will suspend an application. And what this means is that once the process is suspended, the next time a request comes in, we simply resume the process. We don't need to start the process. It's already loaded into memory. It's just paused. So once we resume the process, it's going to be much, much, much more responsive. Because again, we don't have to go through the whole startup costs. We don't need to go through app start. We don't need to load files off the hard drive. And what the IIS team saw when they tested this for real-world applications is a considerable improvement in startup time and a considerable improvement in working set when they enabled app suspension on machines that were hosting commonly used frameworks like Embraco and .NET Nuke. So again, the idea is this is probably more interesting for hosters than it is for application developers, but I did want to make you all aware of the fact that this feature exists, and we do actually have partners using this in the real world. And they are seeing exactly the performance benchmarks that you were seeing here too. Oh, let's see, where did I leave off? I left off at view state. View state, always a, that is not view state. That is view state. Okay, great. View state is always a, always a favorite of the team. Yeah, don't be that guy. Please don't be that guy. We see websites, and I'm not going to name names, but we see websites where the view state, which is a base 64 representation of the page state, can be hundreds of kilobytes. We've seen samples where view state is megabytes in size. Like, we've seen applications that actually store images inside of view state. Now, yeah, exactly, right? They round trip the image from server to client back to server because, you know, why not? It's there, right? So view state is kind of a double-edged sword, right? It was designed originally to make your applications behave as if they were just regular Windows-based applications. When you type text in a web form and then you hit submit, and you know, maybe the page will post back to itself, and you know, the page will actually persist information between the server and client and the server so that the server can keep track of what the client was doing for that particular tab inside that browser. Now, it's great in concept. What we've seen people do, though, is they store images inside view state, or they store like entire ORM objects inside view state. Now, there are, I guess what this should actually be titled is please use view state responsibly. Now, if you look at the new web forms projects templates that we have in Visual Studio 2013, you can see that we actually make use of this new property that we added to the control base class, which is view state mode. What this allows you to do is this allows you to granularly turn view state on and off for the page, or for an individual control, or for an entire hierarchy of controls. Now, why do this? Why not just use page enable view state equals false? Well, one of the controls on your page might actually require view state to behave correctly, and if you just disable view state for the entire page, it's basically, you know, the nuclear bomb of disable view state options. It's a really, really big hammer to wield, where what you really wanted was a scalpel. So what you could do is at the page level, turn off view state via the view state mode property, and on that one control that requires it, maybe turn it back on. Something like this could significantly lower the size of view state on your page, allows compression to work better, you know, reduces the overall size of the request and response. Again, latency goes down, you're consuming less bandwidth. Your mobile clients really will especially love that you're not going through their entire quota just to load a single page with 4 megs of view state. If you're storing stuff in view state directly, you know, just be cognizant of what you're putting in there. You know, instead of storing an entire model, maybe you can store the unique ID, the primary key for that model, so that when the request comes back in, maybe you can just look it up from a database or from an in-memory cache. If all you need is like a little int ID, then yeah, certainly prefer that over storing the entire object itself. And I'm going to say this until, you know, I'm blue in the face. A lot of people are under the impression that setting enable view state MAC to be false will give you better throughput and higher performance. MSDN actually incorrectly said this for quite a while until we, the security team, came down and like basically laid down the law on them. And do not ever do this. If you are doing this, we will find you. We will find you and we will hunt you down. If you do this, we might break you. We do plan on, in the future, forbidding setting this. This is extremely serious. Do not ever, under any circumstance, ever set this property to false. We are so serious about this that we are going to break you if you do it in the near future. So just be aware of that. Oh, okay, so what does the enable view state MAC property do? Haha. I don't actually want to say what it does because then you might be tempted to turn it off. No. So what the enable view state MAC property does is it basically provides, it cryptographically protects view state so the clients cannot tamper with it. If you can imagine that if a client tampers with view state, you know, really bad things can happen on the server because the server implicitly trusts that view state is, to the server, the view state field is implicitly trustworthy. If the client is able to tamper with it and inject malicious data, it's really easy. It's trivial to pull off XSS, for instance. So yeah, don't ever do this. It's an absolutely horrible thing. That's not the only bad thing you can do, but that's the most visible bad thing that you can do. So the question is, why would we ever why would we ever allow this in the first place? Was that the question? So the answer to why it was made is embarrassing. I was not on the team when this was made, but I believe that the answer is that if you are cryptographically protecting view state, then you need to do things like synchronize machine keys in a farm. And I'm sure a lot of you have run into problems with a yellow screen that says validation of view state MAC failed. If this application is run in a cluster, please ensure machine keys are synced, auto-generate cannot be used in a cluster. Like we can quote this off the tops of our heads, right? We've run into it so many times. Our test team did not want to sync machine keys in their cluster. So this property was added and it stayed there and it is regrettable, but it is history. I know I just threw our entire test team under the bus. I really do love our test team. No. This was back like 10 years ago or so, but it is ancient history, and we didn't know at the time that it was as dangerous as it is. So that's really why it's there. Okay, so data access. This is, I think, the last demo that I actually have, but it's one that I think is actually applicable to a lot of applications, especially that are being upgraded from 2.0 to 4.0. Now, for data access, what do I mean by this? For this particular part of the talk, I'm talking about data source controls in web forms. And let me just go straight to the, oh, where's my mouse? Let me just go straight to the demo there. Are we good? We good? Yes, perfect. So I have here, let me get rid of view. So I have here a pretty typical setup. I have a SQL data source. Let me zoom in so everybody can see it better. I have a SQL data source. I have a grid view hooked up to that SQL data source. The SQL data source is going against this sample database.mdf. And this guy is not terribly interesting. He has a table called things, and thing has an ID and description. Again, not kind of a very simple application. And I'm going through, and I'm clicking around through this, and it's showing 10 entries from the table, but I'm clicking on these, and it's taking a while just to show me 10 entries from the database. You wouldn't really expect it to be this laggy, right? Especially since it's just 10 entries. Well, what's actually going on under the covers? There are things like IntelliTrace built into Visual Studio that you can use to see what queries are going on behind the scenes. I'm actually going to use a package called Glimpse that was made by some members of the community. This is an open source package. We'll see if this works because remember I did unplug my network cable. Oh, but I'm on Wi-Fi, even better. Okay, we'll plug you back in. Install package glimpse.ado. So what this is going to do is Glimpse is a utility that allows you to see what's going on during ASP.NET page invocation. It's going to show you things about view state. It's going to show you things about SQL access. If you use MVC, it'll show you things about routing. It's a bunch of plugins into effectively a glorified tracing model on ASP.NET. Basically, it's the ultimate diagnostics tool for ASP.NET. So I've added glimpse.ado, which is a package that allows me to inspect what's going on at the SQL level. I'm also going to add glimpse, install package glimpse.webforms. And this is a package that allows me to see what's going on when my web forms application is being executed. So I've installed both of those packages. It's telling me updates are available. Yeah, that's fine. I'm going to ignore that for now. Kill all of those windows, don't need them. Control F5 this guy. Again, wait 2 seconds. One of the things that Glimpse has done is it has added this little F12-like panel to the bottom of the page. And this is actually rather cool. I can see what's in I can see what's in the ASP.NET object cache. I can see, any interesting configuration sections. I can see, if I'm using routing like MVC, this will show me how long checking each individual route took. For these purposes, or for the purpose of this demo, I'm going to select the SQL layer. And let me go back out here. And as I navigate around, you'll see that, I'm clicking around, and to load 10 entries and show them, this is taking just over a second to execute this query. Now that's rather bizarre. Like, why is that taking place? If I look down at commands per connection, select star from things. I've told the grid view to do auto paging and auto sorting, yet with paging and sorting, like, this isn't even, this is still doing select star from things, even though I'm paging, even though I'm sorting, and it's still returning all 200,000 records from the database. So what's going on here? The answer is that by default, and again, this is where you get your tomatoes ready to throw at me, by default, SQL data source will do paging and sorting at the application layer. So the database just gives you everything, and then SQL data source says, yeah, I can process it all myself, that's fine. And the end result is that the client sees that navigating around inside your grid view takes, 2 seconds or whatever it is in order to just page through this thing. Now, how do we fix this? One of the things that you can do is you can consider using model binding, which we added to web forms in ASP.NET 4.5. Now, how does model binding work? The very first thing that I want to do is I am going to, model one, oh, I'm sorry. The very first thing that I'm going to do is, yes, I'm going to add an entity data model. Let's just call that model. Code first from database. Yeah, code first from data. You know what? Model.edmx isn't valid. Really? Model2.edmx. No, not valid. Oh. There we go. Model connection settings. Whatever. So what I'm going to do is I'm going to generate an EF code first model from what's in the database. Yep, finish. Keep going, keep going. Okay. So this is giving me a thing, correct? Thing, remember my table in the database was things, and a thing has an ID and a description. And my DB context is model. I guess I should have named that model context, but that ship has sailed. In default.aspx, what I'm going to do is I am going to make an iQueryable of thing returning method, which is select things. And I'm going to return the things DB set from my entity DB context that I just created. Now remember, a DB set of T is an iQueryable of T. The nice thing about iQueryable is that you can page it, you can sort it, and that all gets turned into a very nice little SQL query where the database is doing all the heavy lifting of paging and sorting, and the application, in this case, your web server, is just saying, yep, I've offloaded all of that work, life is good for me. The other change that I need to make inside default.aspx is the grid view is no longer using SQL data source. Instead, I'm going to use model binding. What I do is, you saw that I deleted the data source ID property. I am going to add select method equals, what did I call it? Select things. That would have been a bad typo. Select method equals select things. Control F5 this guy. Yes, perfect. You're loading, you're loading, you're loading. Okay, this is fine. This is actually good. I wanted to demo this, believe it or not. And the reason that I wanted to demo this is that if you do use Glimpse to do entity framework introspection in your application, there is currently a bug where Glimpse and EF6 cannot talk to each other. So the way that I'm going to resolve this is the first thing that I want to do is I want to install the EF6 package for Glimpse because I'm using EF6 under the covers. The other thing that I want to do is I am going to install the entity framework package version 6.0.1 instead of 6.1.0. Okay? Again, I'm downgrading EF from 6.10 to 6.01 just to make this demo work with Glimpse. That's fine, it doesn't need to be completely uninstalled. Theoretically, this will work. Yes. And you can see that as I page around here, this is considerably more responsive. I believe that, this is considerably more responsive. Like I can sort ID forward, backward very, very simply. And instead of taking, upwards of a second, these queries are only taking 20, 30 milliseconds each. And you can see that, yes, it's actually doing a proper take, a proper skip, a proper order by. There are, in this case, 2 queries instead of 1, just because it needs to select the count separately from selecting the individual result fragment that it cares about. There are overloads for model binding that you can create so that you don't have to have it, do that select count of 1 every single time. You could imagine that maybe that count you store in HttpRuntime.Cache, there it is, and then you return that so that you don't have to, do that for every single time you want to page into the database. So that's just, something to keep in mind here. What else is there? What else is here? So yeah, one of the other cool things about Glimpse is that, anything that ASP.NET would have traced, you can look here. You can look here in Glimpse and see that. The request timeline, you can see how long it took for the page lifecycle to execute. You can see how long it took for the SQL commands to execute. You can see how long it took for the client to render the page. And I mean, it's just, a great package. I have a link at the end of the slide so that you can get more information on Glimpse. So, what did we cover there? If you are using SQL data source for hooked up to grid views or hooked up to basically anything, try to prefer something like model binding. If you can't use model binding, try using one of the other data sources like queryable data source and returning iQueryable of T from within your code behind. And that will enable us to craft basically a SQL query that has proper take, skip, order by. And that should drastically lighten the load on your application layer. Configuration. There are a handful of configuration elements that control how many concurrent requests ASP.NET can execute. They're listed here. I'm not going to go over all of them in great detail. You can find documentation for all of these online. But basically, if you're seeing that your ASP.NET application can't handle more than, say, 5,000 concurrent connections, check the app host config, ASP.NET config, and machine config to see if one of these is throttling the maximum number of connections that the server can execute. Maximum number of concurrent connections that the server can execute. For applications like SignalR, which have long-running requests, tens, hundreds of thousands of clients, you will definitely have to bump these numbers up. Miscellaneous. This is basically a potpourri of things, just little things that might take you a minute or two to check inside your own website. We see that a lot of people still have debug equals true present in the compilation section in config. That will definitely make execution a little bit less optimal as your application's running. If you are in production, try to set that to false. That second bullet point, compilation. We've seen a few cases where customers will put one ASPX file or one ASCX file per folder, and they'll have 20,000 folders, again, all with one page inside of them. Now, the way that compilation works in ASP.NET is we batch on a per folder level. So if we have 20,000 files in a single folder, we can compile all of them in one shot, and we're really quite efficient at that. If you have one file in each of 20,000 folders, we basically have to call into the compilation system 20,000 times, which, as you might imagine, is considerably less efficient. So if you do see the compilation is taking up a bit of time in your application, the second and third bullet points could be relevant to you. Try to cluster ASPX files, as many per folder as you can, within the realm of reason. Don't put everything in a single folder if your website's not laid out like that. Or, consider pre-compilation, which, yes, you'll pay the cost once up front, but when your application starts, you should see that startup time is significantly reduced. That fourth bullet point there, If you write underneath the www root folder, ASP.NET and IIS have file change notifications set up on that folder. The reason we do that is we need to look for changes to web config. We need to look for changes to the bin folder. And we actually track all changes underneath the website. Now, because there's one file system watcher set up for the entire site, it could be that if you have many, many, many writes to a subfolder underneath there, you could actually overwhelm our file change notification system. And if you do that, we pessimistically assume that that web config changed or that the bin folder changed, and we will recycle the application. So if you are writing to files as part of your website's default behavior, try to make a sister folder to www root instead of a child folder underneath it. Global ASAX, it's kind of unfortunate that when you go file new or file add item global application class, that we put a bunch of empty methods there. Try to remove them if they're empty. Empty methods, we don't know at runtime that they're empty, and we actually have to go out of our way to interrupt IIS, which is in a groove, and we tell IIS, oh, stop what you're doing because you need to execute this method now, and the method says, hey, no, I'll return immediately. And then IIS says, okay, I'll continue. As you might imagine, this calling back and forth between IIS and ASP.NET, not really the most efficient thing in the world. Try to limit the number of entries you have in global ASAX, and any method that's empty, just remove. And your application performance will probably go up. I demonstrated Glimpse earlier. ASP.NET tracing can tell you, what time is spent in various different places in your page lifecycle. You can also use IntelliTrace. You can use App Insights. Their talk is right after this, but I don't remember which room. Check your schedules. Performance counters for diagnostics. I actually have, I guess I wasn't done with the demos, haha. So I have here some performance counters. These are CLR performance counters. And there are some interesting ones here that I wanted to go over. Number bytes in all heaps is how much memory the CLR thinks the application is currently consuming. The number of garbage collections that took place inside the application as it was running. You want the ratio of Gen 0 to Gen 1 to Gen 2 to try to be high, medium, low. You want Gen 0 collections. You don't want Gen 2 collections. Gen 2 collections are, I don't want to say very inefficient, but they're considerably less efficient than a Gen 0 collection. What else is here? Allocated bytes per second, that just tells you if you're allocating too much memory. Percent time in GC will tell you if we're spending too much time in garbage collection. Large object heap will tell you if you're allocating byte arrays that are too large, for instance. So there are, a wealth of performance counters built into the CLR, and I do recommend, taking a look at those as part of your application's regular behavior. Script manager. In ASP.NET, if you've used the script manager control, we actually have an enable CDN property hanging off of it. And the nice thing about using CDNs is you can make us do the work of serving your JavaScript files, of serving things like MS Ajax. That means that if two different websites, example1.com and example2.com, if they're both serving the same instance of MS Ajax and they're both using the CDN, it's great for your clients because your clients can just cache it once and it's applicable to both websites. So yeah, make us do the heavy lifting of serving the content from the CDNs. Try not to do it yourself. That is completely optional. There is also fallback logic. That way if the CDN goes down or you're on an airplane and don't have internet access, we do have logic that automatically says, oh, fall back to webresource.axt. We do know how to do that. Finally, this is the last actual slide, I promise. Weigh 32 versus 64-bit processes. What I mean by that is 64-bit processes, pointer size is twice as large, right? New object is effectively twice as large. Now, if you have things like deeply connected object graphs in a 64-bit process, that will consume twice-ish as much memory as in a 32-bit process. What we've seen some application developers do is they will actually take an application and run it as a 32-bit application pool, and then they'll run a web garden setup. They'll run 4 application pools on their box, each 32-bit, all serving the same website, so that they can get lower overall memory utilization on their 64-bit server. So it's a cool trick that some people do. You could consider, if memory is tight, you could consider it as a potential solution. And finally, don't be afraid to scale out. If you do need to get a different machine, another machine, more memory, sometimes that is the only option. And be aware of, don't fall into the trap of, I want to optimize this more and more and more and more, and then you just start spending more time, more money, when it really would have been more efficient just honestly to get another computer, set up a web farm, and move on to a different project. Resources. You can look at these slides after the fact. These are URLs for everything that I showed up here: Fiddler, WCAT extensions, Entity Framework, Glimpse. My email address is there. Twitter, if you have any questions, feel free to email me. Feel free to contact me on Twitter. I'll also be here afterward. ASP.NET, documentation, samples, everything. And if you do have feedback on this, there's a QR code. You know what to do. Just take a photo of it. And with that, thank you all very much. It is exactly 5 o'clock. Perfect. Take care. And remember, there is the App Insights talk in half an hour if you wanted to go to that. More performance goodness. You all have a good day.